Question 1, we talk about, for question 1, we talk about a low-pass signal has a cutoff frequency in 7 kHz and stop band frequency at 10 kHz. So what is the minimum sampling frequency to avoid aliasing? All right, so first we want to draw this signal. So it's called a low-pass signal. My interpretation is the signal have a frequency spectrum which is look like a low-pass filter. Okay, we know low-pass filter have this kind of shape and have a passing band look like that, and this one it says is 7 kHz and it have a stop band which is 10 kHz. So that means the highest frequency components is 10 kHz. So in order to avoid aliasing, we actually need double the frequency of the highest frequency components. So we need at least 20 kHz. So 20 kHz start from here, and then there will be a 7, so this will be 13 kHz of passing band, and there is a transition, so it barely touch each other, so it will be safe, right? There's no overlap, there will no aliasing happen. So at least 20K, that will be the minimum sampling frequency. So the question asks you, next part is, what happens if you have a sampling frequency lower than that? For example, is 16. All right, so this is 10K, and if we say we got a 16K, what happened? So that will be, so when you're sampling that, the frequency spectrum will be mirrored or will be copied and shifted. So it's 7 kHz apart from that, 7 kHz from 16 is actually 9. So here, right, it will be 9. And then you have a stop band here. You will reach another 3. So in total is 10, right? So this is a 6K. So in the middle here will be 8K. So clearly there are overlap here, which will cause aliasing problem. Okay, so that is the first question. And the second question is to explain why sampling at a Nyquist rate is not sufficient when considered practical DSP system. So the DSP system is you have a signal which is analog, you have analog signal. Before you take the sampling, you want to have a low pass filter. It's called anti-aliasing filter, and this filter will, for example, for this one, what I will give this filter will give it this filter like this. Okay, sorry, this is the filter I will give as an anti-aliasing filter. So that means any frequency components inside the original signal above 10 kHz, it will be cut off. All right, so when you copy that or mirror that after the sampling, there will be no overlap. So then you can do ADC, which is a sampling. That's safe. But in the real case, this is the analog filter. The filter doesn't look like this brick wall. This filter looks like, in the real case, the filter look like this. So it may not be like that, so it will look like this. So the cutoff frequency is 10k hertz, no problem, but the stop band may reach to around 20. So if that's the original signal, that's okay. But if the signal actually itself have some high frequency components, like this, for example, like this. So the signal may have a lot of stuff and go up to maybe 20k, and after this one, we wanna truncate at 10k with a real-world filter. So you combine this in the frequency domain, which is a multiplication. The resulting spectrum is look like this. So you're gonna have something like that. So it's reach. So the cutoff frequency is 10k. So you still have something left beyond 10k. So when you do the sampling, okay, at 20k, you think you double the frequency of the cutoff frequency, but you actually still can have anti-aliasing filter. So there are two ways to solve the problem. First, you can make your filter sharper. You make this filter really sharp, so reduce the transition band, or you can make the cutoff frequency move forward, like 8. So for example, 8k. So, but by doing this, you make sure before 10k there's nothing left, but you also lose some useful information in this frequency band. All right. Another way to do that is, instead of you sampling at 20k, you can sampling at even higher, like 30k, for example. If you're sampling at 30k, then it will start to reproduce itself only at 30k. So it's give you plenty of space between the original and the sampled copy one. All right. So this one, there will be no overlap. That's the first one. The second question.